So this series I'm making for especially for GATE Aerospace, Engineering Mathematics and General Aptitude. So in Engineering Mathematics, I will explain all the syllabus for GATE Aerospace, but for other students also, like if this syllabus is coinciding with you, or this part, like it is common for yours GATE also, like for GATE Mechanical, other branches CS, and so this part will be extremely helpful because I am going to cover. You can see here I have taken like engineering mathematics for GATE complete syllabus with enough practice sessions, means in video itself I'll be giving you complete practice, and for my coaching students I'll be giving them some extra PDFs and extra things to cover, right? But students who are watching this on YouTube, this will be sufficient for self-study students. So let's understand difference between core and special topics. So in special topics, whatever questions are mentioned, whatever topics are mentioned, from there if you check the marks, that is just 10%. It means what? If a question paper is coming for 10 suppose 10 marks engineering mathematics, then out of that 10 mark, only 1 mark will come from the special topics. So special topics, you can see here: Fourier series, Laplace transformation, numerical methods for linear and non-linear algebraic equations, numerical integration and differentiation, complex analysis, probability and statistics. These are the core topic, special topics. So it means what? Out of 10, 9 marks will be from your core topics. So for some students who are very late preparing engineering mathematics, they can skip this core topics, but actually in core topics, whenever question will come, it will be very easy also as compared to the core. But in core, what happens, you have to practice things in more detail, but in special topics, like only lightly if you will prepare, from that question will appear. You can see your previous year question papers as well. So in core topics, what we have to cover for GATE Aerospace, I will explain that. Linear algebra, in that we have to cover vector algebra, matrix algebra, system of linear equations, rank of matrix, eigenvalue and eigenvectors. Okay. Then in calculus, we have to prepare function of single variable, like y is equal to fx, y is equal to sin x, means everything will be in terms of x, and this side will be having y. Limits, continuity and differentiability, mean value theorem, very important. Chain rule, partial derivatives, maxima and minima, gradient, divergence and curl, directional derivatives, these things. Then integration, line, surface and volume integrals, like all the three. So we have theorems also, theorems of Stokes, Gauss and Green, very important. Then differential equation. In differential equation, we have to cover first order linear and non-linear, higher order linear, linear ODEs with constant coefficients, and PDE means partial differential equations, and separation of variable methods. I will explain everything in detail. So I have selected differential equation as my first unit. So I will cover differential equation first. So I am going to cover differential equation and what should be your approach for GATE preparation. So we have to, after learning the differential equation, students should be able to identify what type of differential equation is this. So identify the type. It means it is a degree is this much, it is linear or non-linear, it is homogeneous or non-homogeneous, like these things. Because after understanding the type of differential equation, then only you can actually pick the method to solve that differential equation. So then, like second thing I have written here, apply the correct approach to solve. After identifying the differential equation, you have to go for the method. Go in the direction of the required answer, because we have MCQ, MSQ, NAT and these three types of questions. So like in any particular question, what they're asking, in that flow you have to maintain your solution. I will explain that. So I'm going to cover here what is differential equation, types of differential equation, what are the methods to solve. For example, there is very popular method Laplace. So Laplace I am going to cover, of course, all the methods. Some real life examples in different like equation, in different branches of science and technology, like in electrical, how equation looks like, in like economics also, in our aerospace engineering also. So and then practice questions in the video itself. I'll be giving you enough example so that you can grab very good thing. Then GATE PYQs, actually I have written here PTQs, but it should be PYQs, previous year questions. Topic wise test series. So students who have enrolled with me for GATE aerospace preparation, other than this course, they will also do some additional practice, and then they will go for topic wise test series, and then chapter wise test series, then subject wise test series, and then full length test series. But students who are having a self study here, they can refer some other books as per their comfort and availability and time, and how much time is remaining, everything. So then I'll be taking live doubt sessions on any topic or any question for my coaching students. Okay, fine. So the definition of differential equation I have written here, that is just a fancy word, just I'll explain. Actually, see, differential equation. If I say trigonometry equation, if I am writing y is equal to sin x, this is a trigonometry equation. To write this trigonometry equation, I have taken two variables, y and x. Y is equal to sin x. X is independent variable and y is depending on x. Y is equal to sin x. So dependent and independent variable. So it is trigonometry equation. Y is equal to log x, logarithmic equation. Y is equal to e power x, exponential equation. In that way, we have differential equation. What is differential equation? In that equation, derivatives will appear. Derivatives means dy by dx, d2y by dx is square, or dy by dx whole is square, right? Derivative parts will come. Of course, x and y will also come, or functions of x and y will also come, but mainly derivatives terms like dy by dx, d2y by dx, d3y by dx, and square, cube, these things should definitely come. Okay. So now, right now, whatever you are seeing on the screen here, I have actually explained that suppose you have any algebraic equation, that is y is equal to 2x square plus 9x plus 3. This algebraic equation, if you differentiate one time, then it becomes dy by dx is equal to 4x plus 9. So right now this equation is actually, this equation dy by dx became your differential equation. Why? Because in this equation, derivative dy by dx is coming into picture, right? If you differentiate the same equation again, then d2y by dx square is equal to 4. Again, this became another differential equation. So we are getting these differential equations from this algebraic equation. So this we say as parent equation. Parent equation. It can be algebraic, it can be logarithmic, it can be exponential, it can be trigonometric. Okay, means some set of equations will be there. Those equations, if you will keep on differentiating, how many times it depends. So whatever results we are getting, they are being differential equations. In very large and tough differential equations, you may have like so many derivative terms, so many. When I will show you the practice, you will see that. So suppose you have any equation y is equal to sin x, which is trigonometry equation. That equation, if you differentiate one, like see in this equation, you see, if you will keep on differentiating, then sin will go cos, cos will go sin, sin will go cos, cos will go sin, sin will be cos, like so many terms will come, right? So y is equal to sin x. So if I differentiate one time, I will be getting cos x. So dy by dx is coming into the differentiation equation. So this became differential equation. Even though trigonometry part is there, cos x is there, but this became differential equation. d2y by dx square minus sin x. Again same thing, the equation I have written it again. So this again became your, now what I am doing, see, y is equal to sin x is there, right? So that sin x I am replacing with y. So I have written here, this differential equation d2y by dx square, it is a differential equation that I am replacing sin x with y, correct? Why? Because I have in the beginning itself y is equal to sin x, so I can put in the second equation. So I am getting d2y by dx square is equal to minus y. Okay. So again, this is also one kind of differential equation. So for example, in this differential equation d2y by dx square, you have sin x present, means x term is also present, function of x is also present. But in the last one, d2y by dx square, y is present, right? That sin cos is not present. Okay. So here I have written all types of differential equations can go back to their parent equation by using some special methods. So that is only we have to learn here. Means if there is any differential equation, how to go back to their parent equations. Okay. So mainly we have three things to understand: what is parent equation, what is differential equation, and what is the meaning of solution. Okay. So parent equation means any algebraic equation or trigonometry or some equation will be there. That equation, if you differentiate, you'll be getting some differential form. So that we say a differential equation. There is something called arbitrary constants. These things I will cover soon in the lecture. So you'll be given with a differential equation. After identifying the nature of the differential equation, there are set of methods are there. We have to pick the right one to solve the differential equation and to reach to their parent equation. Okay. For example, if I'll take one extra here, suppose I'm writing y is equal to x plus 1. So what is the differential equation of this? dy by dx is equal to 1. Okay. Now suppose I'm writing equation y is equal to x plus 2, and this equation, if I differentiate, dy by dx is equal to 1. It means what? For this algebraic equation also I have same differential equation, dy by dx is equal to 1, and for y is equal to x plus 2, this is different differential equation, this is different algebraic equation. You can see here we have 1 here and we have 2 here, but differential equation is coming same for both. Means even though constant is not same in the algebraic equation, but differential equation is coming same. That's why whenever we do any kind of research, or first time whenever we convert any kind of physical idea into mathematical model, it always pick the shape of differential equation. That's why some people say that Navier-Stokes equation differential form is like very difficult to solve, or it is impossible to solve. Some people say, I have heard that someone from China or somewhere, they have cracked that they have solved the Navier-Stokes differential equation. Okay, I mean to say differential equation, you have to find out its parent equation, like from which equation it came. Why I am doing that? Why we do this? Because when you will do any research, then you will be having any idea. That idea first you will convert into differential equation, because by logic, when you like slowly I will teach you why it happens. So you will convert your physical idea into differential equation. Then if you are having a right, like if you have enough knowledge of mathematics, then that differential equation you will solve, and then you will be getting a proper equation. That equation can be algebraic, logarithmic, this thing, anything, it can be, right? Now that equation is useful for public use. Okay. So understand the meaning. Taking more examples, suppose I have y is equal to b into a power ax, differentiate one time, y dash means dy by dx. This b is constant, so leave here as it is, e power ax. So a into e power x will come when we differentiate. So again, this b times e power ax I can replace with y. So now my equation will look like y dash is equal to a into y. Okay. You have differentiated one time. Okay. So order is increasing when you will differentiate 1, 2, 3, 4 times. That is the meaning of order. How many times you have differentiated your equation? First time y dash, second time y double dash, means dy by dx, d2y by dx square, like that. That is the meaning of order. Order means how many times you have differentiated. You go to hotel, how many times, how many things you are ordering for your food. So differentiate again. So y double dash is equal to b a e power x. So again a square and b into e power ax you can replace with y. So again this became your new differential equation. Okay. So we are getting differential equations from its parent equation. Differential equation can be of many types, depends on order, degree and constants etc. I will explain. And according to the toughness level and complexity, ये तो रील्स वाला हो गया ना, complexity, we choose the method of solution. Some popular examples from different fields of engineering and technology I am giving here. In economics, we have something called compound interest. I have written here ds by dt, that is equal to rs plus k, where k is annual deposit, s is investment at any time t. Means I am trying to say that in all branches we have differential equation, and all the students of that particular branch, they learn differential equation. I remember long back when I was in Chennai. Long back, a commerce student came to me as a home tutor. I was that time as a home tutor. So he asked me to learn differential equation because he was not having this background. He did only till class 12th. Okay. In chemistry also, you remember we used to do in chemical reaction, equilibrium chapter was there. So there we had a chemical reaction. So there also we used to get this kind of equation, dC by dt is equal to Ka into B. So this A and B and C, they are concentrations of the chemicals, like AB product side, C reactant side, and dC by dt means rate of change of concentration of product with time, right? Anyway, that is not important. I'm trying to say the same thing that in all the fields we have. Suppose you have a freely falling mass m, which is falling. So with air resistance, so you know whenever something falls, like you may be aware of this, if the raindrop will fall, right, it's not like continuously its speed will increase till the surface. No, there is something called terminal velocity. So because of this concept of resistance, viscosity of the air, what happens, this water drop will gain a constant velocity after falling certain distance. Okay, so like for example, it is falling, velocity will increase, and after that a particular altitude velocity will become constant. The last velocity till where velocity was increasing, that we say last velocity we say as terminal velocity. Okay, so for that also we have differential equation. So then we go for something called escape velocity. This I will teach you in orbital mechanics. Then in electrical also, in a RC circuit, dq by dt, rate of change of rate of flow of charge, that is current. So again there also, then dv by, like these things are there. In spring mass vibration, everything no need to note down, just for fancy things I am giving examples. Now in our gate arrow space we discuss this spring mass vibration, right? There we can have this m is equal to d2 x by dt square. Actually it should be square because it is acceleration. Then cv, see this is your inertia force, this is your damping force, this is your spring force, and this is that force what we used to apply, right? Apply means that force for this thing. Okay, so for pendulum also we have same differential equation, and for slope deflection also you have same differential equation. For heat equation, it looks like dou u by dou t k times dou 2u by dou x square. Wave equation, here also order 2, here also order 2. Navier-Stokes equation, etc. They are the live examples of this. So now we have to actually remember the methods how to solve different types of this thing. So this was just an introduction. What we have to do, I will explain further. Actually in this we have to go through types, and I have written somewhere, it seems, just a moment, I think it's not appearing somewhere. I think I have changed the page, but it's okay. This was the introduction about this. So one thing you understand here, if your differential equation I am taking here, suppose you have y is equal to fx, so only one independent variable is there and one dependent variable. So here you will write dy by dx. So whatever equation will come, this you will say as ordinary differential equation, because your y is the function of x only. But suppose your y is the function of x also, suppose x1 also and x2 also, in that case if x1 will change, then also y will change. If x2 will change, then also y will change. For example, area is equal to length into width. So area depends on both. So here you should not say dy by dx1. No. Here you should say dou y by dou x1. So partial differential will come, because y is depending on x1 also and x2 also partially, right? Y is not depending completely on x1. No, it depends on x1 also and x2 also. That's why new concept came, that is PDE, partial differential equations. So that's why if something is written like d2x by dt square is equal to some constant or something, so this becomes your differential equation. But what kind of differential equation? ODE, ordinary differential equation. But if something is written like dou 2x by dou t square something. It means x is not only depending on t, it had some other variables also. X depending on some other variables also. So this we say PDE, partial differential equation. So now point is, either you have ODE or you have PDE. Your ODE can also be of single order or 2 order or 3 order, 1 degree, 2 degree, 3 degree. It can be linear or non-linear. It can be homogeneous or non-homogeneous. In same way, your PDE also can have order 1, 2, 3, 4, blah, blah, degree 1, 2, 3, 4, blah, blah. And PDE also can be linear or non-linear. And your this thing, homogeneous or non-homogeneous. But out of all these types, how much is there in our GATE syllabus? I will explain that. Our GATE syllabus is limited. That GATE syllabus I will show you here on my screen. I have written here. First order linear and non-linear. First order only, order 2 nahi, first order linear non-linear differential equation. Higher order linear means if you go for higher order 2, 3, 4, then only linear. Those kind of we can crack by using Laplace. I will explain that later. ODEs with constant coefficients and partial differential equations and separable of variable methods. We have multiple methods. Out of that, they have given only separation of variable methods. So we will start in lecture 2 types of methods and types of equations. That's all in this video.